Question 4. 3 identical balls slide on a table and hit a block that is fixed to the table. In the figures, we're looking down from above, and this looks very much like something we did in the practicals. In each case, the ball is going at the same speed before it hits the block. Okay, so they all have the same initial momentum. Each collision takes the same amount of time. Rank the magnitudes of the forces exerted on the block by each ball. So here's a bunch of forces. So the whole idea, there'll be an equal and opposite force of the ball on the block and the block on the ball. So I'm going to just use the impulse momentum theorem, which is, we can call it here, momentum. The change in momentum is equal to the force times delta t. Delta p equals F delta t. So for situation 1, what happens is the delta p is going to be, well, for situation 1, you've got, start that over again, the p final is equal to the negative of the p initial. So delta p is equal to p well, it's going to be negative, right? So negative p initial minus the p initial, so it's going to be negative 2 times p initial. So it's going to be 2 times p sub I is equal to F1 times delta t. So F1 is equal to 2. Let's call this magnitude of the force. Just trying to get initial momentum divided by delta t. So there's a 2. And let's make that 2 look a little nicer, shall we? Grab my eraser. Okay, and then for situation 2, it's actually happening in 2D. You've got P final going upwards and P initial going to the right. So the delta P is going to be the hypotenuse of this triangle. So P final in the y direction is equal to P initial in the x direction, and P final in the x direction is equal to 0. So the absolute value of delta P in that case is equal to the absolute value of this subtraction of these two vectors, which are perpendicular. So it's going to be the square root of P initial squared plus P initial squared. That's how you're going to find that triangle. It's going to be root 2 times P initial is equal to the magnitude of the force times delta t. So the magnitude of the second force is going to be equal to root 2 times pi over delta t. And for the third situation, it says captured, so P final equals 0, so delta P equals the initial momentum, and that's equal to this magnitude of the force times delta T, so F3 just equals Pi over delta T. So that's a factor of 1 in there. Let's call it the magnitude. So since, just to sum up here, 2 is greater than root 2 is greater than 1, that means that your F1 is going to be greater than your F2 is going to be greater than your F3. So that's how those are related, and that's answer A.